welcome to my presentation. I was told to keep this short and sweet, so let's jump straight into it. Let me show you my data structures, then I'll take you through the controllers. So let's start with AVL3. So this keeps the filtered issues balanced and ordered. So the most recent table is simply the reversed AVL in order traversals. So basically to keep the issues sorted by ticket number for fast retrieval as well. Then this is my helpers. As you can see, I needed some help from ChatGPT for the rotations. That was a little bit tricky. Here, this is where we insert a new value. Then let me take you through the binary search tree. This is used in the service request controller to quickly find issue by the ticket number. So it basically stores every issue by ticket number. And here's the tree node. So try to find a value in the tree. So this is when it's in order, the ascending order, and then reverse order is the descending order. This is my graph page. So this basically is used in the request service controller to build connections between the tickets, the service requests. So each vertex has a list of neighbor weight, returns all vertices, basically the tickets, add a vertex if not already in the graph, add a weighted edge between the vertices, and return all connected tickets with weights. For comparers, this basically allows the sorting of by ticket and by category then the ticket. It's used by the BST and the AVL for category grouping. So here's my helpers. As you can see, it's logging like the issue saved as issue 004 as 4. And this is where we compare by ticket, compare by the category, then the ticket. Take you through my minimum spanning tree and the union find. So it basically builds the service request and the category, then the ticket hierarchy. So the Razor view can render one table per category. I will show you how that looks when I run it now. So as you can see, we map each vertex to an integer index. We initialize the union find sets here and convert an MST edgeless. And then I also have a sample TFS pre-order over the MST adjacency map. And then this is the union find. So union find disjointed set used in Crystal's MST to check and join connected nodes. We create a standalone set for element X, find with path expression, union by rank, joins basically two sets, return true if merged. Then this is the tree node, basic tree node and array used to model relationships like category, ticket under the categories. Now I will take you through the views and run it. We are using SQLite as a data source. Let me just take you through the views. And then I will just run the project so you to see that it runs and compiles. What is that? Okay, so we have a successful build. Everything is already seeded, so all you need to do is run project. As you can see, we have a home screen plus implemented from part 1. And then if we click here, we can basically report the issue that was shown in part 1, which is now pulled to the request status page. So as you can see, we have it defaulted to the most recent. So how it works is as the issues build, it gets assigned a unique number ascending. So the latest will be 314, 258, as you can see, 241, 172, all going downwards. And then I also categorized it by, well, split it by category. So to show you the binary search tree, let's just search for ticket 314. As you can see, the exact ticket comes up. And if I can show you the entry by applying the category. As you can see, only sanitation is showed. And then let me just reset that. You can also search by status. As you can see, all the in progress show up. Or we can search by outage. As you can see, the outages show up. And then this is where the heap is. Let me just reset this. The heap is implemented here. Each issue is ranked by urgency and pushed into a priority queue. And then this is the priority visit list. Every suitable ticket becomes a vertex in a weighted graph. So we assigned smaller weights to tickets in the same category or nearby locations. So as you can see how they all display. If you see issue 333 is water. So that is my presentation. The queue, let's look at the top urgent. So each issue is ranked by urgency and pushed into a priority queue. Outages have the lowest rank number, so they always bubble up first. The heap returns the 5 most critical tickets instantly without resorting the entire data set. So as you can see, we have it ranked by outages to in progress. And then the priority visit list is basically my minimum spanning tree. So every visible ticket becomes a vertex in a weighted graph. We assign smaller weights to tickets in the same category or nearby locations. And that is the website. Thank you for your time.